Hi, welcome back to ChemTube channel. I'm Jaegu Wong. Today we are going to look at the SBP model questions, set 1 for paper 2. Let's start. First, we look into the section A. It has 8 structure questions. So question number 1. Table shows the chemical formula, melting points and boiling points for carbon dioxide and magnesium. So let's have a look here. So carbon dioxide and magnesium is given here. So referring to the table, state the type of particles in the carbon dioxide. So we know that carbon dioxide is a covalent compound. So what do you think? The particles, it should be molecules. Then number 2, what is the physical state of magnesium at 700 degrees Celsius? So we look at the magnesium here. The melting point is 650 degrees Celsius. And then the boiling point is 1991 degrees Celsius. So at 700 degrees Celsius, so what do you think is the physical state? Yes, it melts already, so it becomes a liquid state. So draw the arrangement of particles of magnesium in the previous questions there. So it is in a liquid form, liquid state. So how do you draw the arrangement of the particles? This is the answer. So the atoms are arranged, okay, not in orderly arrangement, okay, but some of the atoms still can touch with each other like this. So B, diagram shows a part of the periodic table. The letter P and Q do not represent the actual symbol. So given to you P and Q here. So table 1.2 shows the characteristics for atoms of element W and Z. So W, it has the electron arrangement of 2881. Okay. Z, it has the stable duplet electron arrangement. Duplet electron arrangement for Z. So the question asks you, referring to the table, okay, determines the position. So what is the position of element W and Z in the periodic table? So we know that the electron arrangement for W first is 2881. So it has one valence electron, so it should be located at group 1. And then if we look into the electron arrangement, it has 2881. So it has 4 shells. In other words, it is in the period 4. So the W, it should be located at group 1, period 4. Okay, next we look into the Z. Z, it has stable duplet electron arrangement. So meaning that it has only 1 shells with the electron arrangement of 2. So duplet electron arrangement is a stable or stable electron arrangement. It is located at the group 18. So period 1. So this is the answer. Question number 2. Okay, given to you the empirical formula and the molecular formula of 3 compounds here, K, L, and N. So empirical formula and then the molecular formula. Okay, so first state the meaning of empirical formula. So what is the keywords when you define this empirical formula? Yes, it is the formula that shows the simplest ratio of atoms for each element in the compound. Okay, the red color text here is the keywords that cannot be avoid or cannot be missing if you define the empirical formula. So relative molecular mass of the L is 88. Okay, so determines the molecular formula of the compound L. So we use the empirical formula times N. Okay, so empirical formula is C2H4O. So times N, we need to find the value of N equals to 88. So you replace in the relative atomic mass for carbon, hydrogen, and oxygen. So total up, okay, we can find N is 2. Okay, so after you get the N is 2, so what is the molecular formula? So N you times into the empirical formula becomes C4H8 and O2. So this one is the molecular formula because it is the actual ratio for all the atoms of each element in the compound. Okay. B, write the empirical formula for the compound K. So here we know that compound K, the molecular formula is C20H24N2O2. So empirical formula is the simplest ratio, right, of atoms for each element here. So can we simplify it? Yes, we can simplify it by dividing them into by 2. By 2. So the empirical formula should be C10H12NO. Okay, if you have any question, you can type in the chat box. Now C, diagram shows the airbag. Airbag, what in a vehicle which is automatically inflated to protect the passenger during the accident. So sodium azide Na-N3 is used to inflate safety airbags in some of the vehicles. So it decomposes rapidly when heated to produce nitrogen gas N2 that expands the airbag according to the following equation. So sodium azide will decompose to form the sodium and nitrogen gas. So the nitrogen gas actually it can inflate the airbags. So interpret the chemical equation in the quantitative terms. Quantitative terms normally refer to the quantity. So normally we'll refer to the number of mole. So you can refer to the number of mole for the equation here. So how we define it? So it becomes like this. So 2 mole of sodium azide, so decompose to form 2 moles of sodium and 3 moles of nitrogen. So this is the way we interpret it in the quantitative terms. Okay, question number 3. Diagram shows the ingredient of the tomato sauce. Have a look here. We have tomato, sugar, salt, corn flour, artificial color, and sodium benzoate. Okay, so based on the diagrams, state the type of food additives of the sodium benzoate and its function. Okay, so what do you think is the answer? You can type your answer in the box, check box. So type of food additives is for sodium benzoate, yes, it is preservative. So what is the function of preservative? Is to prevent the food from being spoiled by slowing down the growth of a microorganism. So what is the effect of taking excessive food additive sodium benzoate? Meaning that the preservative, no matter what preservative, for a long period of time, if short term should be okay, but if take for a very long time, okay, what is the effect? Do you have any idea? So headache. Headache. Okay, salt is a type of natural food additives. So salt is added to fish and then dry under the sunlight so that it can be kept longer period, for a long period. So explain the function of the salt. So how the salt function? So actually it can prevent the food from being spoiled by removing the water and inhibits the growth of the microorganism. yeah, it can remove the water from the food. Okay, actually it is a kind of preservative as well. Now name another substance that has the same function as salt. So besides salt, actually another example, we can put sugar. Question number 4. You are given 3 atoms, carbon atoms, oxygen atoms, and then magnesium atoms. So let's have a look on this electron arrangement. Carbon, first shell is 2, second shell is 4, so 2, 4. For oxygen is 2, 6. Magnesium is 2, 8, 2. Okay, 2, 8, 2. So we know that carbon and the oxygen is non-metal. Magnesium is a metal. So which elements is a metal? So only one, magnesium. Okay, very simple. Now, if oxygen react with magnesium to form a compound, so oxygen is a non-metal, magnesium is a metal. So metal with non-metal, so it will form what? Compound. Can you type your answer in the chat box? Yes, it is an ionic compound. Ionic compound. So here, ask you the compounds, don't write bond. If you write bond, it's wrong. So it's ionic compound. So write a balanced chemical equation for the reaction in this one. So oxygen react with magnesium. So magnesium is a metal, oxygen is a molecule, so O2. So it forms a magnesium oxide, right? Okay, magnesium oxide. So this is a balanced chemical equation. So this one times 2, this one times 2, so that it is balanced. Okay, so draw the electron arrangement of the compound form. So we know that magnesium is 2, 8, 2. Okay, oxygen is 2, 6. Correct? So how to achieve octet? So magnesium, you lost 2 electrons, then received by the oxygen atom. So magnesium, it forms magnesium 2 positive. Oxygen receives the 2 electrons from the magnesium, so it becomes 2 negative. So they are attracted by the strong electrostatic force. So this, the charge 2 plus, 2 positive, oxide is 2 negative. Okay, so don't put a plus sign in the middle here because they are attracted by the strong electrostatic force. Now step 1, physical property of the compound. So it is an ionic compound, so it has a very high melting and boiling points. Okay, question number 5. Diagram shows the 2 beakers A and B that contains a solution of ethanoic acid prepared by dissolving the glacial ethanoic acid in 2 different solvents. Alright, okay, glacial ethanoic acid means it is pure ethanoic acid without water inside. So in beaker A, you can see the pH shows it is 4.0, but in beaker B, it shows it's still in the neutral form. Okay, so this is ethanoic acid. So in different solution, different solvent, so it will show the different pH. So what is the reason? Yeah, so set the name of the suitable solvent. So if it can show the acidic property, so meaning that what is the solvent? Yes, it must be water. So it can ionize in water, produce a hydrogen ions, meaning that the hydrogen ions is freely to move here. Okay, so it can show the pH 4. But inside the beaker B, the ethanoic acid still in the molecule form, so it cannot show any acidic properties because there is no hydrogen ion. So what is the solvent in the beaker B? Yeah, except the water, for example, any suitable organic solvent. So here given to us, suggested, yeah, like methyl benzene. Okay, it can accept any suitable organic solvent. Okay. Now explain the pH value of ethanol acid in the beaker A. Just now we mentioned already. So what are the points? So 3 marks here. So point number 1, glacial ethanol acid ionized in water, right? So the keywords ionize, okay, ionized in water, so to produce the hydrogen ions. So the hydrogen ions is present, so it shows the acidic properties, no? Okay. Okay, B, table shows the pH value of solution PQRST. So each solution has the same concentration, which is 1 mole per cubic decimeter. So we know that if pH lower than 7, it is acidic, right? Acidic. Okay, so pH 7 meaning that it's a neutral. Okay, and then more than 7, it is alkaline. Okay. So which of the solution has the highest concentration of hydroxide ions? So hydroxide ions belongs to alkaline. So if highest concentration, the highest pH value, meaning that is T should has the highest concentration. So explain your answer why. Why we know that T is the it has the highest concentration of hydroxide ions. Okay, so solution T. So how to explain? So it is a strong alkaline. Okay, strong alkaline. It ionizes completely in water to produce high concentration of hydroxide ions, right? Hydroxide ions. Okay, so the higher the concentration of hydroxide ions, the higher the pH value. Okay. Question number 6. Diagram shows the apparatus to determine the heat of displacement. Okay, here 100 cubic centimeter is a volume, 0.5 mole per cubic decimeter copper 2 nitrate. This is a concentration. Okay, with the excess magnesium powder. Okay, so a thermometer is used to measure the temperature. Table shows the result of the experiment. So initial temperature of copper 2 nitrate solution is 28 degrees Celsius. So the highest temperature of the mixture is X degrees Celsius. So first state the meaning of heat of displacement. Okay, so displacement reaction is a displacement of a metal by a more electropositive metal, right? Okay, so the heat of displacement heat of displacement is a heat release or heat change when 1 mole of copper, so this is the metal that is being displaced in this case, so displaced by magnesium from the copper 2 nitrate solution. Here is the heat release or heat change, and then 1 mole of metal is being displaced. So here is a copper being displaced by the magnesium. Okay, next, the apparatus of the apparatus used in the diagram cannot be used to reduce the rate of heat loss okay, to the surrounding. Suggest a suitable apparatus to solve this problem. Okay, in this case, the one used is using the test tubes. So the correct one, or if we want to reduce the rate of heat loss, so we should use polystyrene cup. Yes. Okay. Now, if the magnesium powder is replaced by silver plates in this experiment, so predict the heat change and give a reason. So here, so just now we know that magnesium react with copper 2 nitrate. Okay, so magnesium is able to displace the copper, so it forms a magnesium nitrate and the copper is being displaced. Okay, so here if mentioned here, if now the magnesium is replaced by the silver. So what do you think? Is the displacement of copper by the silver is happen? Okay, should be no. Why? Okay, so silver is not able to displace the copper. So the temperature, the heat change should be no change, or no change in the heat. Why? Because the standard electrode potential value for the silver is more positive than copper, right? So it cannot displace the copper from the copper to nitrate solution. So you can refer to the standard electrode potential list for the silver and the copper. Okay. Next, if the heat of displacement of the experiment is negative 42 kilojoule per mole, so determines the highest temperature of X. Okay, specific heat capacity is given here is 4.2 joule per gram per degree Celsius. Okay, so first we need to find the number of mole for the copper 2 nitrate. Okay, so first we need to calculate for copper 2 nitrate. So we use the MV over 1000. So M is 0.5, V is 100 over 1000. So use your calculator. You can calculate. You get is 0.05 mole. Okay. So next we need to find the mole ratio. Okay, so mole ratio is 1 to 1 or 1 to 1. So here we know that the delta H given to us is negative 42 kilojoule per mole. Okay, so delta H is the Q over the mole. So we get the mole, we have the delta H, so we can calculate the Q. So Q equals to the delta H times the mole. So is 42 times mole is 0.05. During our calculation here, because the Q is not exo or endo, so no need to put in the negative sign. Okay, so you will get is is 2.1 kilojoule. If we change to joule, it will be 2100 joule. Okay, so we have the formula Q equals to MC theta. So Q here is 2100, M here is 100, C is 4.2. Then we can find the theta. Okay, so here our theta you get is 2100 divided by 100 times 4.2. So you get is 5 degrees Celsius. Okay, but this is not the X, right? X is the highest temperature. So your X value, it should be the initial temperature is 28 plus the highest, the X is 5, so it's 33 degrees Celsius. Okay. Now calculate the mass of the magnesium that react completely with the when the copper 2 nitrate solution is used. Okay, so here we know that the number of mole, just now we calculate already. So number of mole we use the MV of 1000, 0.5 times 100 divided by 1000. So you get is 0.05 mole. Okay. So the mole ratio is the same. It's the same. So magnesium also 0.05 mole. Okay. So the mass of magnesium we get will be mole 0.05 times the molar mass for the magnesium is 24. So you will get is 1.2 gram of the magnesium is being react okay, with the copper 2 nitrate solution. Okay, question number 7. Diagram shows the apparatus for the electrolysis process of cell X and Y using the carbon electrodes. Okay, so PQRS. So electrolysis carried out for 30 minutes at the fume chamber. Okay, so here given to us, this is the battery. So the longer one is positive, negative. Okay, so meaning that this one is positive, this one is negative. So here cell X is molten lead 2 iodide, cell Y is hydrochloric acid. Okay, 1 mole per cubic decimeter. So meaning that this one is the concentrated acid. Okay. So let's list out, okay, all the ions that are present. So here you can note down, okay, molten lead 2 iodide. So it has lead 2 ions and then iodide ions. So here no water inside because it's a molten state. But here is the solution. So hydrochloric acid, what are the ions present? We have hydrogen and then chloride. Okay, solution you have hydrogen and another one is hydroxide ions. Okay. Now, okay, state the cathodes in cell X and cell Y. So cathode is the negative terminal. So negative terminal here. Okay, so this one negative, this one also negative, this one positive. So it should be R and Q, right? Okay. So cell X is Q, cell Y is R. Okay. Now write all the formula for the ions present in the molten lead 2 iodide. Okay, so there are 2 just now we mentioned already. So lead 2 ions and then iodide ions. So step 1 observation at the electrode P in cell X. So electrode P is the anode, positive terminal. So this one is anode, anode. Okay, so iodide will forms the iodine. Okay, so meaning that what happens here? So iodide will undergoes oxidation, right? Okay, so lost the electrons, so it forms iodine. So iodine, you cannot write the iodine gas it release. So observation, so iodine is a purple gas. So purple gas is released. Okay, so half equation is for the Q is the cell X, so it's a cathode. So lead 2 ions undergoes reduction, gain 2 electrons to form the lead metal. Okay, so this is a half equation. Now based on cell Y, okay, state the product as electrode S. So electrode S, okay, is the chlorine gas. So okay, then the product in here change the moist blue lemon pepper to red when bleach, and then bleach. Write the chemical equation for the reaction. So chlorine gas, so chloride, it forms a chlorine. So lost 2 electrons. So actually this one is undergoes oxidation. Okay, so electrode X is an anode. Anode always undergoes oxidation. So how does the concentration of the electrolyte in the cell Y change after the electrolysis is carried out for half an hour? Okay, give a reason. So initially we choose the chloride ions is discharged because it's higher concentration, right? So the concentration will be decreases. Okay, decreases. Why? Because chloride ions has discharged into the chlorine molecules, right? Because the concentration of chloride ions is higher than hydroxide ions. Okay, but it will decrease after half an hour. Okay, question number 8. In year 2018, okay, this school had won the 3rd place. Okay, trophy they received kept in the school gallery. The trophy still looked shiny. Okay, so the trophy is made from what? From bronze, the real bronze. So set the main elements in the bronze. Yeah, so this is alloy. So what do you think? You can write your answer in the chat box. Yes, copper. Okay, so draw the arrangement of atoms in bronze in the space provided. So what do you think? Bronze, it is a combination of copper and tin. Yeah, copper and tin in the alloy of bronze. So how do we draw it? Yeah, you can draw and then label it correctly. Huh? So tin, it has a bigger size compared to copper. Okay. So 2 marks. Make sure that you label it after you draw the arrangement of the atoms. So bronze is used to make the monuments. So explain why does the bronze is suitable to make it in terms of arrangement of atoms, or in terms of why it is harder. Okay, so have a look here. So in pure metal, okay, all the atoms are from the same size, right? Okay, so when the force is applied, the layers of atoms can slide over one another easily. Okay, but in the alloy, okay, because of the different sizes of the atoms here, when the force is applied, so the layers of the atoms cannot slide over one another easily. Okay, so copper atoms and the tin atoms are different size. So tin atom disturb the orderly arrangement of the copper atom. So as a result, when the force is applied, the layers of copper atoms and tin atoms do not slide easily. Okay. Okay, table shows the manufactured substance in the industry and its composition. So given to you, first is a photochromic glass. So substance X and silver chloride. Substance Y, it has iron, carbon, and chromium. So what is the question? So substance X is the main component that makes the photochromic glass. Set the name of the substance. So it's actually is a glass, right? So it's a glass. So give a property of the photochromic glass. So photochromic glass, actually, if you look at here, okay, in the under the sunlight, it becomes darkened. Under the normal one, okay, normal place, it turns to transparent. So photochromic glass becomes darkened when exposed to bright light, and then clear when exposed to dim light. Okay, so you can have a look here. Now substance Y is harder than pure iron. Okay, explain why. So this one almost the same as this one. Okay, so substance Y is a stainless steel. So the foreign atoms to reduce the layers of the atoms from sliding over one another easily. Okay, so it cannot write prevent. It cannot be prevent. It can only reduce. Okay. So next we are going to look at the section B. Okay, is the essay questions. 2 essay questions. You choose one to be answered in the exam. Okay, but in this video I will explain, or we will discuss both questions, so that you can get more information or knowledge on the questions. Okay, essay question number 9. 3 experiments 1, 2, and 3 are carried out to investigate the factor affecting the rate of reaction. Table shows the reactants and the condition of the reactants involved. So here, reaction 1, zinc, excess zinc, react with hydrochloric acid. So concentration is 0.1 mole per cubic decimeter. So temperature here is 30 degrees Celsius. Okay. Here is the time taken for the X mark to disappear from site. Okay. If you notice this, this label actually is wrong. Why? Because in this reaction there is no precipitate is formed. So this one should be wrong. So the correct one should be the time taken for the time taken to collect, let's say 50 cubic centimeter of hydrogen gas. Okay, So because inside the reaction, then it will release the gas. So for the X mark to disappear from site, normally is for the reaction between the sodium thiosulfate with the sulfuric acid. Okay, so sometimes the questions also got mistake, yeah? So you have to be careful on that. Set 2, okay, assessing the same. Okay, same concentration also for the acid with set 1, but the temperature is higher. Okay, so the time taken is 30 seconds only. For set 3, okay, assess zinc with hydrochloric acid, also the same concentration, but it has a copper 2 sulfate as the catalyst, if you notice it. Okay, temperature same as 40 as set number 2 will be the same, then time taken is shorter, 20 seconds only. Okay, now first question, write the chemical equation for the reaction between the zinc and hydrochloric acid. Okay, so the chemical equation, zinc react with an acid, produce a salt, zinc chloride, and the hydrogen gas. So the hydrochloric acid need to times 2 so that it is balanced. Then calculate the maximum volume of hydrogen gas produced in the experiment 1. So what is the volume of the hydrogen gas? Okay, so here we know zinc is in the excess, so meaning that it's extra here. So the limited one will be the hydrochloric acid. So the concentration and the volume over 1000, you can find the number of mole. Okay, so number of mole for the hydrochloric acid is mv over 1000, concentration 0.1, v is 25 over 1000, you get 0.0025 mole for hydrochloric acid. Okay, but for the question asks you about the volume of the hydrogen gas, so you have to do the mole comparison. So 2 moles of hydrochloric acid produce 1 mole of hydrogen gas from the equation, right? So in the calculation, 0.0025 mole of the hydrochloric acid, it will produce half, 0.00125 mole of the hydrogen gas. Okay, so the mole for the hydrogen gas is 0.00125. So can you find the volume? Yes, definitely, right? Volume equals to mole times the molar volume. So molar volume is 24. So you get 0.3 cubic centimeter, cubic decimeter, or 30 cubic centimeter. Okay. So the maximum volume collected in the reaction will be 30 cubic centimeter. So meaning that just now I give the example, it should be 30, not 50, 30 cubic centimeter of the hydrogen gas. Okay. If you have any question, you just type in the chat box there. Okay, now sketch the graph of the volume of hydrogen gas against the time for the experiment 1, 2, 3. So here we know experiment 1 takes 50 seconds, experiment 2 30, experiment 3 20 seconds. So meaning that set 3 will be highest rate of reaction, okay, followed by set 2 and set 1, right? Then volume of the gas collected, okay, we see the mole, so mv over 1000. So we can see all are the same. Okay, all are the same. So meaning that set 2, set 3 highest rate of reaction, so the gradient is the highest, the steepest the gradient, then followed by set 2, then set 1. Volume of gas collected will be the same. If you want to label here, actually is also can is 30, right? 30 cubic centimeter. Okay. Okay, next. Based on the table, arrange the rate of reaction for the experiment 1, 2, and 3 in the descending order. Descending order meaning that is from highest rate of reaction to the lowest rate of reaction. Correct? So the arrangement will be like this. Experiment 3, and then 2, and then 1. Okay? 1 mark. Then state and explain the factor for the experiment below with the reference to the collision theory. So you have to know how to explain the factor affecting the rate of reaction using the collision theory. So first you need to compare set 1 and set 2. Set 1 and set 2 just now we discussed already because of the temperature, right? So first point, temperature of the experiment 2 is higher than experiment 1. So you have to use the comparison word. Okay. Then what is the next point? So the kinetic energy because of the temperature. So kinetic energy of the particles here will be the hydrogen ions from the acid. In the experiment 2 is higher than experiment 1. Okay. So no matter what acid, the particles, it should be hydrogen ions. Okay, so you pay attention here. So next point, frequency of collisions between the particles. So here acid is hydrogen ions from acid, and then zinc is a metal, right? So it's a zinc atoms. So they will collide during the reaction. So frequency of collision between the hydrogen ions and zinc atoms in experiment 2 is higher than experiment 1. Then point number 4, after you mention about the frequency of collision, then frequency of effective collisions. Okay, the remaining are the same as the point number 3. Between hydrogen ions and zinc atoms in experiment 2 is higher than experiment 1. Okay. Okay, next we are going to explain the experiment 2 and experiment 3. Okay. So in experiment 2 and 3, so it's a factor of catalyst, right? So experiment 3 has a catalyst. So copper 2 sulfate used as a catalyst in the experiment 3, but not in experiment 2. So you have to explain which experiment has a catalyst, which one don't have. Okay. Then the catalyst lowers the activation energy for the reaction between the zinc and the hydrochloric acid. Okay. So more colliding of the particles, you have to mention hydrogen ions and the zinc atoms can achieve the lower activation energy. Then frequency of effective collisions between the hydrogen ions and zinc atoms in experiment 3. You have to mention which experiment is higher than experiment 2. Okay, so 4 marks. Okay, so this is how we write the correct points for the essay questions. Okay, next, fruits that store in a refrigerator last longer than the fruit left on a table. Explain why. So here I think it's quite obvious. It's a factor of temperature. Correct? So in the refrigerator, the temperature is lower. If you left on a table, the temperature is higher. So how are we going to explain? So we explain the refrigerator temperature. The temperature in the refrigerator is lower than the room temperature. Okay, so point number 2, the bacteria activity is lower in the refrigerator. So next, lax toxin is produced by the bacteria in the refrigerator. So the rate of fruit spoilage is lower in the refrigerator than in the room temperature. Okay, question 10. Okay, a student carry out an experiment to construct an ionic equation for the formation of lead-2 iodide. No? So 7 test tubes of the same size are labeled 1 to 7. So 5 cubic centimeter of 1 mole per cubic decimeter potassium iodide solution is poured into each test tubes. So the volume of the 1 mole per cubic decimeter lead-2 nitrate solution is added to the potassium iodide solution as shown in the table. So the height of the precipitate formed in each test tubes is measured. So the result is shown in the table. So here we have 7 test tubes here. Okay, 1 to 7. So the volume of the lead-2 nitrate solution is added is test tube 1 0.5, test tube 2 1.0 until 3.5. Okay, in test tube 7. Okay, then they will react with the potassium iodide, right? So you forms the precipitate of lead-2 iodide. So the height of the precipitate form is measured by a ruler. Then you measure down. Okay, so here actually you can see it obviously. After the test tube 5, the height of the precipitate remain the same, correct? Okay, what is this means? It means the reaction actually is completed already, because there is no more increase in the height of the precipitate form. Okay, so meaning that after test tube 5, the reaction is completed. Okay, so let's have a look on the video, okay, regarding the continuous variation methods.
You are going to carry out an experiment to construct the ionic equation through the continuous variation method. How can the ionic equations of the reaction between barium chloride and potassium chromate 6 be constructed through the continuous variation method? The apparatus needed to carry out the experiment is shown. Place 7 clean labeled test tubes of the same size in a test tube rack. Add 5.00 cubic centimeters of the potassium chromate 6 solution into each of the 7 test tubes using a burette. Using another burette, add the barium chloride solution into each of the test tubes according to the volumes shown in the table. Stopper and shake each test tube well. Allow 30 minutes for the precipitate to settle. Observe the color of the solution and measure the height of the precipitate in each test tube. Using the table shown, plot a graph of the height of the precipitate against the volume of barium chloride added. Click on the points on the graph provided.
Okay, so based on this video, okay, it's slightly different with the one in the question there, but it's okay. This is the reaction between the barium chromate and then with the lead-2 nitrate, okay, if I'm not mistaken. Okay, so it forms a barium chromate, which is also yellow color. The one in the question is lead-2 iodide is formed. Okay, so this is how we conduct the experiment. Hopefully you get some ideas on it. So plot a graph on the height of the precipitate against the volume of the lead-2 nitrate solution. So 4 marks. So here is a suggestion. So height of the precipitate. Okay, so you can plot the graph. First, volume of the lead-2 nitrate is 0.5, so is 1.1, so on. You can plot like this. Okay, so after 2.5, they become constant here, the height. Okay, in actual fact, during the exam, so this is the first point, so no need to extend to 0, no need. Okay, so you just start with the, from the first point is enough. Okay, so height of the precipitate centimeter, unit must be stated. Volume of lead-2 nitrate cubic centimeter. Okay, unit must be stated correctly. Okay, then is the shape of the graph. It should be a straight line and then it become constant after the test tube number 5 just now. Okay, so here determines the number of mole of the lead-2 ions and then the iodide ions that are required to form the lead-2 iodide. So your answer should consist the following. So first is the volume of lead-2 nitrate solution that had reacted completely with 5 cubic centimeter of 1 mole per cubic decimeter potassium iodide solution. Okay, so here we know that this now is 2.5 okay, cubic centimeter, because after that the height become constant already, means reacted completely. Okay, so 2.5 cubic centimeter. Number 2, calculate the number of mole of the lead-2 ions and iodide ions. We use the MV or 1000. So lead-2 ions is 1 mole per 1 times 2.5 over 1000, so 0.0025 mole for lead-2. Okay, meanwhile for the iodide also the same, not the same, so 1 times 5 over 1000, so 0.005 mole. Okay, so if we do the comparison, okay, so calculate the number of mole for the iodide ions that had reacted with the 1 mole per cubic decimeter. So we do the mole comparison. Okay, so 0.0025 mole lead-2 react used to forms a 0.005 mole of iodide, right? So meaning that if 1 mole, double, right? So it's times 2, is 2 mole. So from here we can write the ionic equation correctly. So 1 mole of lead, Pb2 plus, react with 2 moles of iodide, right? To produce a lead-2 iodide is a solid yellow precipitate. Okay, so this is the half equation, ionic equation. So this method is called continuous variation method to determine the ionic equation. Okay, next, one sample of river water is taken to test the presence of lead-2 ions, and then by using the chemical supply below, describe the chemical test to determine the presence of lead-2 ions in the sample. So you are given sodium hydroxide solution, ammonia, and then potassium iodide. Okay, first I will show you one diagrams. Okay, so if we use the sodium hydroxide, a few drops, any precipitate forms? Yes. So lead is here, so it forms a white precipitate, right? Then white precipitate soluble or not, in excess sodium hydroxide, dissolve. Okay, but dissolve is still have 3 zinc, aluminum, and lead. Okay, then insoluble will be magnesium and calcium, which involve the white precipitate, right? Okay, so this is the first line, right? Okay, to get this. But there are 3 ions will get the same result. So we have to use the ammonia later. So ammonia, okay, we add in few drops. Okay, whether it produce the precipitate or not. Okay, yes, lead is here, right? So white precipitate soluble or not, it will dissolve. Dissolve. So dissolve, it will only have zinc. Okay, zinc. So you can differentiate with this one already. So not soluble, insoluble. So lead is here. Okay, so here zinc already can be differentiated because aluminum and zinc, it will insoluble. So here aluminum and lead, okay, aluminum and the lead, you will have the same result. So we cannot differentiate these two. So we have to use the third one, potassium iodide. So you can use the potassium iodide to differentiate the lead and then the aluminum. Okay, now I show you with simple video for lead. What is the observation? Okay, add in a few drops of sodium hydroxide solution. Okay, it forms a precipitate, white precipitate. Then in excess, you shake it and then you will soluble in excess. Okay, sodium hydroxide solution. Okay, so this is for sodium hydroxide. Okay, for ammonia solution. Okay, a few drops, you forms a white precipitate. Okay, and then in excess ammonia, okay, you forms a white precipitate. Okay, it's insoluble in excess. Okay. So how are we going to differentiate the aluminum and zinc? So aluminum and lead. Okay, aluminum and lead. So we use the potassium iodide. Okay.
Use a dropper to add about 1 cubic centimeter of potassium iodide solution into a test tube containing lead-2 ions.
So it will form the yellow precipitate.
Add about 3 cubic centimeter of distilled water. Boil the mixture. Cool the mixture using running water from the tap.
So you can see after you add in the potassium iodide solution, it will form a yellow precipitate. Okay, so add in some water and boil the mixture. So some yellow precipitate, it will dissolve, meaning that this lead-2 iodide is soluble in the hot state. And then when you cool it under the running tap water, the golden yellow crystal are formed. So it forms back the yellow crystal, turns back to solid again. Okay, so how are you going to write this point? Okay, so we put 2 cubic centimeter of sample river water added into a test tube, then add in sodium hydroxide solution a liter at a time until excess. So white precipitate form, and then it was soluble in excess sodium hydroxide solution. Okay, so it shows the presence of possible can be lead, aluminum, and zinc. Okay, so we cannot differentiate, so we have to do for the ammonia. Repeat step 1 to 3 using ammonia solution to replace the sodium hydroxide. So white precipitate insoluble in excess ammonia solution. So the possible one can be lead, magnesium, and aluminium. So magnesium actually can be cancelled because it's not present in the step number 3 here. Okay, so we just need to differentiate the lead and the aluminium. So add 2 cubic centimeter of potassium iodide solution into 2 cubic centimeter of river water into the boiling tube. Then yellow precipitate is formed. Okay, then you heat and then you cool it. Yellow precipitate soluble when hot and then reform as a crystal, yellow crystal when it is cooled down. Okay, so 10 marks for these questions. Okay. Okay, next we are going to look at the section C, essay question. So only one essay questions here, so you have to compulsory to answer the questions. So you have to train or practice more on the section C essay questions. Okay, question 11. Diagram shows a compound Q that is widely used for the manufacturing of the surgical gloves. So this is substance Q, is a latex, right? Then this is used to make the surgical gloves. So explain how to ensure that the compound Q remains in the liquid state. Okay, remain in the liquid state while being transported from the estate to the manufacturing plants. So meaning that we have to add in some chemicals, right? Do you know or do you remember what is the chemicals need to be added? Okay, you can type in the checkbox. So 4 marks. So first we look into the simple video.
Addition of ammonia or alkalis helps to maintain their negative charges. This will keep the rubber particles to repel each other and the latex remains as a suspension.
Okay, so we know that addition of ammonia normally, okay, is a weak alkali. So the points, first we add in the ammonia, is added to the latex. So ammonia solution contains the hydroxide ions. It will neutralize the hydrogen ions that is produced by the bacteria. So the latex, the protein membrane actually remains negatively charged. They will repel each other, okay, from colliding with each other. So the latex cannot coagulate. Okay, so 4 marks. Now B, diagram shows the conversion of compound W to compound X and Y. Compound W has a molecular formula of C2H6O. Okay, so normally we will convert it or make it to a more familiar format is C2H5OH, right? So this is the C2H5OH is the ethanol, right? Okay, it's the ethanol. So ethanol undergoes oxidation, so it forms the compound X, right? So compound X, oxidation, so it forms the ethanoic acid, right? CH3COOH. Okay, then reaction 1 is you produce a carbon dioxide and water. I think you should know what is this reaction. It's a combustion, yes. Okay, then here for reaction 2 we use the porcelain chips, right? It forms this compound Y. So porcelain chips, do you still remember what is this process? Yes, it's dehydration, right? Remove the water, right? So it forms a ethene. Okay, so if you can label like this, I think you should be able to answer the questions easily. So state the name of the compound W, so it's the ethanol, correct? Then name the homologous series and state the general formula for compound Y is here, is alkene. Okay, and then state the name and draw the structure for X is the carboxylic acid, so ethanoic acid. Then the reaction 1, so it's combustion. So here 6 marks. You can score easily. Okay, so W is ethanol. Homologous series of Y is alkene. General formula is CnH2n. Okay, N must start from 2 because alkene, it has carbon-carbon double bond. Okay, the name of the compound X is the ethanoic acid. No? Okay, next structural formula for compound X. So it's here ethanoic acid. Okay, so this is a functional group, COOH. Then finally, reaction 1 is combustion. So 6 marks. Okay, you write point by point based on the marks allocation. Okay, next, by using the compound W, describe how the compound Y that obtained can be prepared in the lab. Okay, by reaction 2. So in your answer should include list of the materials, procedure, and then confirmatory test and observation. Okay, so here I will show you a video first. This is how the dehydration takes place.
Click the play button to see what happens when ethanol vapor is heated strongly over porcelain chips.
Okay, test with bromine water first. Okay, the brown bromine water you decolorize. Okay, so if we use the acidified potassium manganate 7 solution, okay, so it turns to colorless also. Okay, the brown acidified potassium manganate 7 it turns to colorless. The purple color turns to colorless. Okay, so the materials, we need the ethanol, glass wool, porcelain chips, water, bromine water, acidified potassium manganate 7 solution. Apparatus, boiling tube, test tube, stopper with delivery tube, red top stand, Bunsen burner, beaker, and dropper. The procedure, so place a glass wool in a boiling tube and then pour around 2 cubic centimeter of ethanol into the boiling tube and to wet the glass wool. Then place the porcelain chips in the middle of the boiling tube. Then heat the porcelain chips with a strong flame. Then heat the glass wool with a gentle flame to vaporize the ethanol. So the vapor is flow through the heated porcelain chips. So in this stage, it will absorb the water from the alcohol. Okay, so collect the gas by displacement method, displacement of water into 2 test tubes. So test the gas collected by shaking with a few drops of bromine water, and then another one with acidified potassium manganate 7 solution. Okay, so these are the steps or procedure. So record the observation. Remember how? Okay, so confirmatory test. So what can you confirm? So bromine water, so brown bromine water change to colorless. Okay, another one, acidified potassium manganate 7. So purple color of the solution, it turns to colorless. Okay. So that's all for the SBP set 1 model question in paper 2. Okay, do subscribe our channel and then like this video and share with your friends. So all the best to your SPM exam.